So we're going to call this contract for the first time, see the result on, we're going to use Laura, the Explorer, the new one that came out, which is absolutely beautiful. And we're also going to, after we call create archer successfully, we're going to add unequipped bow, equip bow, and shoot arrow. So we're going to create a new file, and we're going to call it call my archer.py. And we're going to import some things that are new. We're also going to reuse some of the things we already have been using. So from algosdk.v2client.algod, import algod client. And then the node token, also import OS. And then the node token is going to be os.getEnv, node token. I believe that's what we called it here. Algod token, excuse me. So algod token. And then we're going to do the same for the server. Node server is equal to os.getEnv. And we call this algod server. And then we can create our client here. Algod client is equal to algod client. Pass in the node token and node server. We're going to need our private key again. So private key is equal to os.getEnv. Private key, I believe we named it. Yep. And let's see. So what we need to do is create a application client. So we're going to walk through this step by step. Let's import this here from AlgoSDK, or actually AlgoKits utils, import application client. And what this is, it's an instance of the application combined with the clients and the JSON for the contract, as well as information like the app ID, parameters, and also it's going to have a signer, which is something that signs trends. It's basically compiling everything a contract would need to be interacted with into a single object, which is application client. Otherwise, you would have to declare everything manually, sign manually. It's much easier. It's pretty useful. A pretty useful feature that AlgoKit comes with. And if you weren't using application client before, for application calls, if you're already developing on AlgoLearn, you should start using it immediately. And I'm going to walk you through creating an application client. So application client, and then it tells us what we need here. So the first thing it needs is an algod client, which we already have here. Algod client is equal to algod client. The next thing that it needs is the application spec, which is going to be basically kind of like when we use with open here in launch smart contract, but it's going to be for the JSON here. And we're also going to use path instead. So path, it's not a with statement. I'll show you here. It's going to be new to you, most likely. But it's a similar concept to the with statement when we open the approval and clear programs. So path is going to be equal to path file. And then we're going to say the parent. And this is archer.arc32.json. And let's start organizing this so we can see it line by line. So app spec is equal to path. Next up, it wants the app ID, and we should have put that in our env. Yes, we did. Let's go back here. So we're going to say app ID is equal to os.getEnv app ID, whatever you named it here. So I named it app ID. And then here, app ID is equal to app ID. Next up, we need a signer. So a signer we're going to import. So let's go here. From Algo SDK dot count transaction composer, import account transaction signer. And we're going to create a signer here. Signer is equal to account transaction signer. And then we're going to pass in the private key that we imported from our end file. Oh, we actually have to leave that here. Next up is the address, I believe, sender. So sender is equal to, and we haven't imported that yet, or created that yet, so we need from algo SDK.count import address from private key. And address is going to be equal to address from private key. We pass in our private key. We declare here. And lastly, we're going to need params. And then we will be done with creating our application client. So suggested params is equal to, and we can just create params here. Params is equal to algodclient.suggested params. And we are done creating our application client. And now we can interact with our contract using this. So when we have our application client, it has methods in here. So you have the attributes of the application client, like the app ID, suggested params, the client we're using, the app address, which we didn't pass here, it just automatically translates the app name, which is not defined when we create it, but this is the beauty of the application client. It can give you details about your contract that you don't have right off the bat. And then you have here compose call. And this is how you prepare an application call to your contract using the application client that we just created here. And it's a lot simpler than anything else any other method you'll ever use. The only catch is that we need to import one more thing, and it's going to be the atomic transaction composer. And an atomic transaction composer is basically just, it builds the calls you're going to make to the contract. So you can create a group transaction with a bunch of application calls using the atomic transaction composer and the application client together. So we're going to say ATC, atomic transaction composer, is going to be equal to an instance of an atomic transaction composer class. So we create an atomic transaction composer object here. And the compose call always wants this first. And it needs to be a positional argument. So every time you use a compose call, just include this brand new atomic transaction composer at the beginning. And then we're going to start adding transactions in here. So next up, call ABI method. And what this is basically just the name of your function. So create Archer. That's going to be a string. And then lastly, we're going to pass in this argument, x. And the application client automatically reads it, knows what the argument's going to be. So we just put x equals, and let's say 5. So 5 arrows. Because what x is here is going to be defined as, it's going to be used as the local state for the user, the arrow's local state here. Okay, and we're going to see this in action shortly. And there's one thing that we do need to add, I mentioned earlier. So to create a local state, which is what this method does, a user needs to be opted in to the contract. By default, ABI methods only accept no-op transactions, which basically means don't opt in when you make this application call. So we need to specify here that we do want to allow the user to opt in. If you don't specify that, it's not going to allow you to do it. So in here, we're going to say allow actions, and it's going to be a list of all the actions we're going to allow. You have closeout, delete, no op, opt-in, and update application. We're going to type in opt-in. So when we call this application call, when we call this method of our contract, the user is allowed to opt in only. And we're going to go in here. And now we need to include transaction parameters. And it's going to be a dictionary of whatever you want to pass in. There are a lot of things you can pass in. You can do a note field in here. You could do arguments, or not arguments, but you can do box references. And especially, most importantly for us right now, you can pass in on complete. So here are all the things you can use: counts, boxes, foreign applications, foreign assets. And we're going to get into using all of these later on, not in this video. But for now, we just need on complete. And it's going to be a key and values, so it's a dictionary. So the value is going to be, and we're going to need on complete. Let me just organize this a little. And it's going to be from the transaction module from the Algo SDK. We're going to import on complete. This is going to be on complete opt-in. So when this application is called, make sure you opt in to the contract. And once you're opted in once, you cannot opt in twice. So this will be something we only call once ever per user. And to get the results, we're going to just say ATC, the Atomic Transaction Composer, with this new call inside of it, dot execute, and we're going to pass in the algot client, and we're going to wait 2 rounds. I've tried waiting, and don't forget this comma here. I've tried waiting 1 round. It doesn't, it errors out for some reason, so I've just been using 2 since then. And we're going to print results dot ABI results, and it's going to be the first result because it's only 1 transaction, and using index notation, which we learned about when we were doing list comprehension. It's going to be the first index, which is 0. So 0 index notation. We're going to get the transaction ID. And that's pretty much it. So let's call this transaction. Let's call this method and see what happens. Hopefully no errors here. App ID was a string. So the application client wants the app ID as an integer. When we read from our .env, even though it looks like an integer here, it's going to interpret it as a string. So where we define our app ID, we need to just convert it to an integer. And then we'll be all set. No signer provided. We forgot to include the signer here. It's my mistake. So signer is equal to signer, which we define here. And let's see what comes up next. Assert failed on complete. Because when we created the contract and compiled it, we did not add the allow actions yet. So what we're going to do is we're going to compile it again. Make sure you save, Control S, or go to File, Save. Use AlgoKit compile, pi, and then the name of your smart contract file. And now you're going to see here in our approval, or ARC32, that this just changed from no op to call. And now we're going to launch our smart contract again, using our handy dandy launch smart contract.py, get the new application ID, go to our env file, paste in the new ID, Go back to call my archer, and let's try it again. And it looks like it's going to go through because it's waiting 2 rounds, and we get the transaction ID. So now that we have our transaction ID, let's go to the browser and type in AlgoKit, LoRa, and you should get this here, LoRa.algokit.io. And it defaults to testnet, I believe. We can paste in the transaction ID from the terminal that we got here. And results should pop up. And we'll see here our application call. Transaction ID, the application we're calling. And over here in global state, you'll see that Arch is created, although we initialize it to be 0. And here is now 1 because we increment by 1 when create archer is called. Here's the value, 1. And the local state delta, what changed? Arrows is now 5 for this address, and bow equipped is 0, which is false. So these two things changed because we set arrows to the argument x, which we set to 5 over here. And then we declare that initially the local state for bow quit for this user, this sender, will be false. And next up, we're going to create the ABI methods for equipping and unequipping the bow, as well as shooting the arrow. So we're going to knock these out all at once. So let's start here, ABI method. And we don't need to include opt-ins anymore because we're already opted in. And we're going to say def equip bow self returns none. We're going to assert, as we asserted here, that the bow, excuse me, the bow equip is going to be false initially. So when we shoot the arrow, the bow has to be equipped. When we equip the bow, what we're doing here is saying assert self.bowEquipped is equal to false. So they should only be able to equip the bow if it's not already equipped. So here we're going to say asserts self.bowEquipped for this sender is equal to false. And we can copy and paste this and say unequip bow and assert that it's going to be true. And then we're also going to say self.bowEquipped for this sender is going to be set to true. Copy and paste this. And when they unequip, set it to false. And then we're also going to create an ABI method for shooting an arrow, self, return none. And once we try all these out, we're going to look at how to return values here. We're going to be returning tuples. So we're going to assert that self.bowEquipped for this user and their local state is equal to true, because you can't shoot an arrow unless you're holding the bow. And we're also going to change the amount of arrows this user has. We're going to subtract 1 from the 5 arrows that they have. And let's see here. And we should also assert that self.number of arrows they have is greater than 0. Because if you don't have arrows, you shouldn't be able to shoot arrows. And this looks good. Let's compile this. And you can hit the down and up arrows in the terminal to get previous commands. And we're going to compile my Archer again. Make sure you save and hit File, Save, one or the other. So you can hit File, Save, or Control S. And if we go to our JSON, you'll see we have our new methods here. And these do not take any arguments, so this is empty. And there are no return statements, so these are all void. And these are no op. So it means nothing happens. There's no opt-ins, application doesn't update, it just executes whatever's in the code here. So let's give this a try. And what we can do, well, first off, we need to create the new contract with our new approval and clear teal. So let's run launch smart contract again, get the app ID, go to our end file, paste this in. You can save this to be sure it works. Usually don't have to. And go to call my Archer. And what we can do, we're going to write this once and then copy and paste it. Compose call, include the ATC again, and call ABI method is going to be set to the name of the method, which here is equipBow. And there are no transaction parameters needed, and there are no arguments needed. So this is all you need to do. And then we're going to do this not 3 times. We're going to change the methods here to unequipBow and shoot arrow. And what this is going to do is create a group transaction where we create the Archer, we equip the bow, we unequip the bow, and then we shoot arrow, which is actually backwards. We're going to unequip the bow, actually. Let's equip the bow, unequip the bow, equip the bow again, and then shoot arrow. That makes sense. Because we can't shoot an arrow if the bow is not equipped, but I do want to show all of these transactions in action. And this should be good. We only need the transaction ID for the first one. But what we can do is, and this is a bit more of an advanced concept, we can say transaction for transactions, or hold on, let me think this through. Transaction for let's do this. Transaction for result ABI results I for results ABI results. Transaction for results ABI results I for I in range 0 length results.ABI results. And this is, give me 1 second. Okay. We don't need this in the beginning. Perfect. Good. And now we can print all the transaction IDs. And this is kind of an advanced concept. Even I, like when I write it, I kind of need to think about it. But what this will do is go through every result in ABI results, and the index will be I in the range of 0 to how many results there are. So if there are 5 results, it's going to use for I in range of 0 to 5, gets result.abi results I. So results.abi results 0, result.abi results 1, etc. until 4. 0, 1, 2, 3, 4. Just a total of 5. So let's run this, and we should get all the transaction IDs. Transaction already in ledger. So something to understand is that when you create application calls or any kind of transaction at all, say I wanted to send 10 payment transactions, they will all be completely identical. There will be nothing that distinguishes one from the other, and that will give you this error, transaction already in ledger. So you're submitting duplicate transactions. So what we can do here, we can include transactions. So we have a duplicate here, the quit bow. So what we can do is add transaction parameters here, and instead of on complete, we're just going to place a note in here and say extra equip bow transaction, whatever you want. You can technically just put anything here, 1 or number 2. I'm just going to put extra equip bow transaction. And that's going to be in the note field of the application call when we execute. This should be good. I'm going to clear this, hit run, and hopefully everything will execute, which it looks like it is. It's waiting 2 rounds. And here we go. We have 1, 2, 3, 4, 5 transaction IDs. 1, 2, 3, 4, 5 application calls. If we go to LoRa, you can just take the first one, paste in the transaction ID, and then we can click on this here, group. And then you'll see 1, 2, 3, 4, 5 application calls. And we can go to each one. So we already looked at the first one, which is create archer. And we saw that the global state incremented by 1 per archers created. And the local state we set to 5 arrows here. And the user also opts in here, and as well the bow is equipped is not equipped. So bow equipped is initially set to 0, which is false. And if we go back, we go to the next transaction ID. So the next transaction is equipping the bow. And if we look here, this will be a local state delta. Bow quit is now set to 1, which is true. And then the transaction afterwards was unequipping the bow. So that means local state should be set to 0, which it is. And then the next transaction was equipping the bow again. This time with the note field, extra equip bow transaction. So if you go here in the note field, at the bottom, you can see that note is there. And local state delta, it's set to 1 again. And lastly, we shot an arrow right here. So if we go back to our group, click the last transaction, local state, you're going to see that the only thing we did with the local state in our contract was assert that equip bow was true, assert that arrows was greater than 0, and then decrement arrows by 1. And you'll see here we now have 4 arrows left in our archer. So what we want to do is return, I'm going to show you how to return results, or return values actually, from the contract. Because optimally, you don't want to go online and check the blockchain manually in an Explorer to see the results of your application calls. So what we can do is we can actually include return statements in this contract so that we can see those results in real time when we get the transaction IDs in Visual Studio Code. So for example, when we create the archer, maybe we want to return an archer was created. They have X amount of arrows now. Their bow is or isn't equipped. And the contract has created this many archers so far. So what we're going to do is here, we're going to import string, which is actually going to be a part of the ARC4. And we're going to say return string. An archer was created. And then we can say another string. Archer has this many arrows. And then we can include X. And then we can also say contract has created this many archers so far. And then include here the self.archers created.value. And so we can also say here, return, space this out, return string. Archer equipped their bow. And then we can return either 0 or 1, self.bow equipped for this user. We can do the same thing on the next method. Archer unequipped their bow. And then here for shoot arrow, we can say archer shot an arrow. And another string, arrows remaining. And then we can include here self.arrows, transaction sender. And because we're returning things now, when I mentioned earlier that we need to indicate using type notation for the function what is going to be returned. So this returns a string and an integer, self.bow equipped. So that's going to be 0 or 1. Same thing here, we return a string, another string, an integer, a string, and another integer. And then string, integer, string, string, integer. So all of these nones, they need to become these types here. So we need to indicate that we're going to be returning all these things. And the way to do this, since we have multiple values, is by importing something called capital T, tuple, from the ARC4 library of AlgoPy, aka Puya. So, for example, here we return string, string, integer, string, integer. So we're going to say here, tuple, string, string, or actually, give me 1 second. It's actually not this one. It's the lowercase one, the native Python one. So remove the tuple import. It's going to be lowercase t, and then open and shut brackets, string, string, uint64, string, uint64. And then we're going to do the same thing here. So instead of none, we're returning a string and an integer. So string, and this is technically a bool. So we're going to say bool, but it does evaluate to an integer. And then here, same thing, string, bool. And then here, string, string, and arrows is an integer. So let's complete that here. String, string, uint64. And this should be good. but we can confirm that by compiling. So Control S here to save, then hit Enter. And let's see, perfect. And if we go to our JSON, you'll see that these have all changed. So create Archer, and now it doesn't return void, it returns this tuple, string uint64, string uint64, and here string bool, and string uint64. And we're going to use a similar list concept here, but instead of using the transaction ID, we're going to pass in, so we're going to adjust this slightly, return results, or return value, and that's pretty much it. And what I'm going to do here is I'm going to say transaction IDs is equal to, instead of printing this, so we can have it legible, and results, or ABI results, is equal to, remove these extra parentheses, and then for I in range of length of transaction IDs, or we can say correctly result.ABI results. We're going to print transaction IDs, I, and print ABI results, I, and then we're going to add a little spacer here so everything can be organized. Let's launch our new contract, or our updated contract, and then let's copy and paste the new application ID that we get. And let's try call my Archer again, and hopefully all of this works out. Perfect. So instead of checking online on an Explorer what happened, we can get the results directly here. So for this transaction, the create Archer, it says an Archer was created. Archer has this many arrows, 5. Contract has created this many archers so far, 1. And then here, Archer equipped their bow, true. It does evaluate to a bool here, true or false, but when you check the global state online, it does say 0 or 1. And then here, Archer unequipped their bow, false, is the state of the bow equipped. And then here, Archer equipped their bow again, so the state of their bow being equipped is true now. And then here, Archer shot an arrow, arrows remaining, 4. And what I'm going to do here is create a second account, since we're already opted in. And we're going to say private key 2. And you don't have to do this, I'm just showing you that's the global state is not per account. It's for the contract itself to store. And then we're going to take this address, go to bank testnet, just fund it really quickly, copy and paste the address, and then go here to call my Archer. And we're going to change this to private key 2, as we named it here. And we're going to run the script again. And we're going to say, I should have probably changed the quantity, so maybe 10, but it's fine. And then you'll notice here, contract has created this many archers so far too. So now we have 2 users with local states in the contract. And that's pretty much it. So this is a pretty simple contract. But these are all the concepts you'll really need for knowing how to work with the local states and global states, ABI methods, returning values from the ABI methods. I'm trying to think of what we might do next. I'm thinking perhaps some sort of like staking pool. But this is going to be the end of this video. All the code's going to be uploaded to the GitHub. But if you have any questions, feel free to reach out to me. And let's get started on our next contract, the next video. Thanks for watching, guys. I hope this was informative. And yeah, on to the next.